ये तो द्विभाषी चर्चा होगी तो so this will be a bilingual presentation. सच में मुझे भी काफ़ी डर लग रही है, खासतौर पर उतनी अच्छी चर्चा के बाद आने की वजह से। So अगर हम तो वितरित अंकरों के बारे में बात करते हैं, आपको क्या सोच आती है? So what comes to mind when I mention the term distributed data? कोई भी अंकित जी के अलावा आपको पता है? हाँ जी? Exactly. So data is often centralized on a server, and distributed data is a bit the opposite of that. तो पहले से ही बोलूँगा इसके बारे में बोलूँगा कि क्यों वितरित अंकरण चाहिए हमें. So first I'll start a bit with why this is important. नागरिक विज्ञान के बारे में सुने होंगे. Citizen science rings a bell for I think a few people here. Has anybody worked with citizen science? अच्छा अच्छा. तो आमतौर पर जब हम नागरिक विज्ञान के बारे में बात कर रहे हैं, हम उस विज्ञान के बारे में बोलते हैं जो इंसान से बनी जाती है, जो वैज्ञानिक नहीं है. So it's a bit of an umbrella term that encompasses all science that is done by people who are not scientists by profession. तो यहाँ एक उदाहरण है, उसका नाम है टेरा स्टोरीज. और वहाँ तो खास तौर पर मध्य और केंद्र और दक्षिण अमेरिका में आदिवासी लोग की भूमि की सुरक्षित करने के लिए एक उपकरण का प्रयोग करते हैं. So this is a tool often used, Terra stories, in Central and South America by indigenous populations to delineate and protect their ancestral territories. कोई और है? यहाँ तो क्लार वाटर है. ये तो चित्र खींचते हैं नदी और तालाब की, खासतौर पर यूरोप में. It's a German project actually. I think, or perhaps Swiss. It is in German though, and it's basically a project where citizens take pictures of water bodies and share them to contribute to monitoring water bodies that couldn't be monitored as well with a professional, more expensive sensor networks. और यहाँ संयुक्त राष्ट्र अमेरिका में भी ऐसे एक क्लार हाइड्रोलॉजी रखे हैं. So we have also the same system in the US as well. और प्राकृतिक खतरों के लिए भी हैं ऐसे ऐप बनाए चुके हैं, जैसे कि यहाँ भूकंप के लिए एक ऐप है बर्कली से. And we've seen these apps as well being developed for lots of different fields, including natural hazards, such as here for earthquakes developed by Berkeley. पर ये तो कैसे काम करते हैं? How do these sensors actually work precisely? What's the magic behind them, right? तो आमतौर पर यहाँ तो एक गांव से तो इंटरनेट एक टावर से मिलेगी. So internet connection happens through an internet tower, which then goes to a server usually in a large city. तो उसके बाद एक बड़ी शहर तक जाएगा, वहाँ एक सर्वर होगा जो उसके सेवा को प्रदान करता है, और फिर वापस सर्वर से गांव पहुँच जाएगा. So then this is a bit of an inefficient setup. काफ़ी अप्रभावी व्यवस्था है ये. अगर कुछ होता है तो इंटरनेट नहीं मिलेगी. So when a disaster happens, this happens to be the time when we most need these services, and it's also the time when they're most likely to be unavailable because the infrastructure can go down. क्या कर सकते हैं उसके बारे में? एक व्यवस्था है जिसका नाम है अंतर्गृह संचिका प्रणाली. So there's a system, new system has been developed. It's called IPFS. Anybody heard about it before? So it stands for Interplanetary File System. So it's a very ambitious name, but the project is also very ambitious. So it does live up to the promise of its name. And the idea with this is that the internet from today would not work in an interplanetary setting. तो आज जो अंतर्जाल हमारे पास है, तो अगर हम दूसरे ग्रह को जाते हैं तो वो काम नहीं करेगी. क्यों? देखिए, रोशनी की तेज कितना है और दुनिया कितनी बड़ा है. पूरी दुनिया ऐसा गोल गोल आने के लिए आपको तो एक सेकंड से बहुत कम समय लगेगा. So the speed of light, it takes much less than a second to traverse, to go around the world once, which means that when we connect with the internet, the delay is in the establishing the connection, is in the server response time. It has nothing to do with the actual speed of light. It's 0.13 seconds. हम तो चंद्र तक जाएं तो एक सेकंड से ज़्यादा हो जाएगा. Now, if we were on the moon, it would take a bit more than a second. So it would start being a bit inconvenient, say for Skype or WhatsApp calls, but it's still manageable. पर अगर हम मंगल तक जाएं तो 12 मिनट जाने के लिए या 12 मिनट वापस आने के लिए. Now, if we went to one of the closer planets, Mars, then it would be over 20-minute round time. So forget any FaceTimes, forget any video calls. And if you were doing a Google lookup, then it would be 20 minutes back and forth from the Google server. So not not very useful. अगर हम एक स्थानीय जाल बना सकते हैं तो फिर ज़्यादा जल्दी हो जाएगी ना. If instead of having a centralized system, we had a decentralized internet, then information, say, would travel from the server. I'll lose the mouse so you can see. So the server is here. The information would travel once and it would take 12 minutes. But then, if we're making a second query, there's no point in going back to Earth and back to Mars. We could get it locally from here. And in that way, it becomes a lot more efficient and a lot faster. The first connection takes time. Later, it spreads rapidly and locally. तो ये वैसे ही नहीं बोल रहा हूँ, सच में ये तो अंतरिक्ष में इसका प्रयोग की चुकी है. So there's already been a demonstration with Lockheed Martin of using IPFS protocol in space, and it did work. तो इस स्थिति में गांव में ऐसा कुछ इंटरनेट नहीं मिले तो फिर भी एक दूसरे से संपर्क की जा सकती है, क्योंकि हमारे स्थानीय जाल है, और फिर भी दोबारा ठीक हो जाता है तो फिर दूसरे गांवों से संपर्क भी मिल सकती है. So the advantage of such a system would be, a distributed system would be that when the internet is gone, you can still communicate locally with whoever is in the same room in the same local network. And as soon as connectivity is reestablished, then you can connect again with other regions, which makes for the development of much more stable, much more resilient apps for disaster management, because they always work to some extent, and we only have a bit of a delay, say, with syncing with the wider internet if there's a problem of connectivity. तो हमारे आज तक हमारे अंतर्जाल सबसे ज़्यादा केंद्रीकृत प्रणाली है, जैसे कि Google, WhatsApp, email, जो भी हो. Our internet today, almost everything you use, whether it's email, Google, WhatsApp, is a centralized system. If you send something to me on WhatsApp, you're not sending it to me. You sent it to WhatsApp in probably Bengaluru, and Bengaluru just sent it back to me, even though we're in the same room. इसके बाद विकेंद्रीकृत प्रणाली बन चुके हैं, जैसे कि blockchain, cryptocurrency, सब ये. So the first step towards decentralization was building decentralized systems, a bit like blockchain, cryptocurrency, Bitcoin. But उसमें पूरी तरह से विकेंद्रीकृत नहीं है. उसमें सबसे ज़्यादा काफ़ी बड़े-बड़े सर्वर की ज़रूरत होती है. अगर आपके पास बिटकॉइन हो तो आपके फ़ोन में नहीं रहेंगे ना, कि सर्वर से रहेगा और उस सर्वर से आपको सेवा मिलेगी. So if you're buying say Bitcoin on your phone, which I would not recommend, but say you did, then you don't have Bitcoin on your phone. Most likely it's on a server elsewhere, and they're providing that service to you. So in the end, they tried to decentralize. I think it was a good idea. That didn't really work out because we ended up with the worst of both worlds. Very inefficient, environmental catastrophe, and at the same time, we still have servers because the system is much too heavy to put on a regular computer, much less on a telephone, for example. और अर्कर में सच में वितरित प्रणालियां हैं, and जिस पर हम काम कर रहे हैं. So what we're working on is actually a truly distributed system, not just decentralized, but completely distributed, in which the software is light enough to live on a cell phone, on a touchscreen cell phone that could say it could belong to a farmer or somebody in a village. तो आमतौर पर नागरिक विज्ञान में क्या होता है, हम आंकड़ों लेते हैं, फिर सर्वर में रखते हैं, फिर सर्वर की दोबारा से अनुमति की जांच की जाती है और एक बड़ी संचिका में रख लेते हैं सारे आंकड़े. उसके बाद सब लोग को उस आंकड़ों तक पहुंच मिलती है और फिर क्या होता, पैसे खत्म हो जाते हैं, सर्वर बंद और आंकड़ों खत्म. So what happens usually in a citizen science project, we start collecting data, we send it to a server, we pay for that server with project funding, it gets added to a centralized database, people can access it, everything is well and fine until the project funding is over and the data disappears once the server is taken offline. Even if it was collecting or providing real service to communities, if there's nobody to pay for the server, they can't access their own data, which brings up questions of data sovereignty and long-term sustainability. Now with Constellation, which is our distributed data software, it starts the same way. तो वितरित प्रणालियों के साथ ऐसे ही शुरू हो जाती है, पर फिर भी हम न हो तो फिर भी चलती ही रहता है क्योंकि पूरी सॉफ्टवेयर लोग की दूरभाष में रहता है. So in a distributed system, even if we're gone, even if we lose interest and lose funding and move on to another project, it keeps on working because the entire hardware necessary for the system to work is on our users' devices. So as long as it's useful for them and as long as they decide to keep on using it, they have no need for us. We can connect to the network, collect data, download data on our computers, run analyses, or we just can decide we don't want to do that and we want to move on to something else. It doesn't matter, as long as it's providing real value for the communities, they can keep on using it indefinitely. So there's a few differences in thought that we need to take into account when we're moving, or say philosophical differences in building these systems. One of them is that there's no single source of truth. For in your email account, the source of truth is on the server. तो अगर आप email के प्रयोग करते हैं तो अंकरों के एक ही अद्वितीय स्थिति है और वो सर्वर पर है. सर्वर आपको बताता है कि आपके संदेश कहाँ से है, किसको संदेश भेजी है. All the information on your account status at this time is all on the server. एक वितरित प्रणाली में ऐसा नहीं हो सकता है क्योंकि कोई सर्वर नहीं है. तो हर कोई किसी भी प्रतिभाग उसमें तो वो तो अंकरों की एक अद्वितीय स्थिति बन जाता है. So it means that everybody in the system becomes a source of truth for sharing the data. I'm not any more a valid source of truth if I have the software on my computer there than you are if you're participating in the same system. And anybody can access data either from me or from you, no matter who's written to it or who it belongs to. And then the difference is content-based addressing. So the entire internet works with location-based addressing, which means that if you ask for Google, your browser can't go to google.com. It doesn't know where google.com is. It goes to a server, asks where is google.com. The server sends the IP address back, and then it looks up that address and accesses Google. If we're working with a distributed system, we can't do that because what we do instead is we make a hash of the file. So we look at the file, the content we want to access, and every content has its own unique code. And then we say, I want this code. And anybody who has that file can send it to us. तो उसके उदाहरण दे दो. HTTP में आम अंतर्जाल में अगर हम किताब ढूंढ रहे हैं तो वैसे ही गए कि हम पूछ रहे हैं कि गांव के पुस्तकालय की उत्तर दीवार की दूसरी अलमारी की दाहिने से तीसरी पुस्तक चाहिए मुझे और वहां से किताब देते हैं. अगर कोई चोर आके दूसरा किताब रखे तो आपको दूसरी किताब मिलेगी. वैसे ही हैक कर देते हैं वेबसाइट को. So in the centralized system what we have now is based on what's present at that location, at that address. And if somebody has gone in and changed the book there, then you'll get the wrong book. That's how they hack websites, right? They go in and they change the content without anybody noticing. इस प्रणाली में ऐसा है कि हम कहते हैं कि मुझे महाभारत चाहिए. मुझे फर्क नहीं है कहाँ से ढूंढ लेंगे पर मुझे चाहिए लेके आ जाओ बस. So in these systems, the equivalent would be, the equivalent analogy would be to say, well, I want Mahabharat, this book. And I don't care where you find it, which library or which bookstore you find it, just bring it to me. And it'll look wherever is available and bring that book to you by the, in this case, the analogy would be the ISBN code. So there are software that have done this type of project before. QE was very interesting. Unfortunately, they went bankrupt. We don't have any money, so we're not going to go bankrupt. There's no worry about that. और हमारे सॉफ्टवेयर का नाम है तारामंडल. So it's called Constellation. और ये है अगर आप चाहते हैं तो उसमें काम करके या ये सही लिख के फिर आपको जानकारी मिलेंगे उसके बारे में. You can go on to the QR code here or the link below to get the information. Don't forget the accent on the E. Without the accent, it will not work. It's a Canadian project. So this is how the software looks. We're very proud of the interface. We spend a lot of time making it pretty and nice. तो उसमें अपनी profile बना सकते हैं. You can make your profile photo, your contact information, and all this is shared in a distributed manner as well. So if you connect to Constellation now and look at my profile, it will move directly from my computer to yours. It won't go through any server. Actually, you won't know because I closed my computer now, but when I'll open it, you'll have access to it again. तो वैसे ही और आप भी देख सकते हैं कि अंतर्जाल में किससे संबंध में है. So this is also a list for more advanced users, but basically you can see other peers in the network that you're connected to directly with the IP address. So it looks up and manages the connections for you automatically because most people don't want to do that. उसमें तो variables बना सकते हैं. So you can create variables, keywords, databases, and these will sync automatically between users of the network. उसमें तो अलग-अलग भाषा में लिख सकते हैं. तो आप हिंदी में, अंग्रेजी में, फ्रांसीसी में जिस भाषा में भी लिखना चाहिए तो लिख सकते हैं और हर किसी यूजर उसको अपनी भाषा में देख लेगा. So you can add your data in as many languages as you like, and every user will automatically see your data in their preferred language. So it helps you get more of an international reach for your projects. और उसमें हर किसी तरह के आंकड़ों जोड़ सकते हैं. तो संख्या, तिथि, मितन, चित्र, वीडियो जो भी चाहिए. So this has support for any type. It's a bit like Google Sheets, but it has support for any type of data. So you can have photos, videos, dates, numbers, text, arbitrary files, anything you like. So you can build quite interesting apps on top of this with support for any type of data to share. और यहाँ के उदाहरण है जो हमने कंबोडिया में किए. वहाँ तो पानी में नमकीन के बारे में आंकड़ों लेने के लिए एक ऐप है. So the original interface is for scientists. It looks like Google Sheets. Now, if you're doing an app for citizen science, you probably don't want it to look like Google Sheets. So you can build your own interface. For example, this is an example from Cambodia, from groundwater salinity in wells. And it just interfaces with the Constellation API, which is still locally held in your app. And the users don't have to look at variables or keywords. They just enter the data and it shows up in tables or maps, however you like. तो उसमें हमें दूरभाष और अंतर्जाल की apps है. We have apps for phone and internet, as well as installable apps. We have Python, Julia, and R clients, which we'll go a bit into in the short course tomorrow. We have a programming interface to build your own apps. And finally, we're working on a pinning server to keep data available even when your computer or your users' devices are off. और सब बिल्कुल खुली स्रोत मुक्त स्रोत में है. So of course everything is free and open source, so you don't have to pay anything to use it. And you can use it and build anything else, something better on it as well, as long as you share the code back, of course. उसके साथ मैं धन्यवाद कहता हूँ.